Hello everyone, I'm Neeraj Kumar from CSCB section. In probability and statistics, now we're going to discuss about multiple correlation. Multiple correlation coefficient. The multiple correlation coefficient denoting a correlation of one variable with multiple other variables. Multiple correlation coefficient. The multiple correlation coefficient is denoted as R of a comma bc till k, which denotes that a is correlated with bcd up to k variables. R of a dot bc is equal to root over rab square plus rac square minus 2 rab rbc by 1 minus rbc square, where r a dot bc is equal to is multiple correlation between A and linear combination of B and C. RAB is equal to is correlation between A and B. RAC is equal to correlation between A and C. RBC is equal to correlation between correlation between B and C. The following table tells about the academic achievement, anxiety, and intelligence for 10 subjects of a particular student. Subject 1. Academic achievement is 15, anxiety is 6, intelligence is 25. Subject 2. Academic achievement 18, anxiety 3, and intelligence is of 29. In subject 3, academic achievement 13, anxiety 8, intelligence is 27. Subject 4. Academic 80 is 14 followed by anxiety 6 and it is followed by intelligence of 20. Subject 5. Academic achievement is 19, anxiety 2, and intelligence of 30. Subject 6. Academic achievement 11, anxiety 3, and intelligence 21. Subject 7. Academic achievement 17, anxiety 4, and intelligence 26. Subject 8. Academic achievement 20, anxiety 4, and intelligence 31. Subject 9. Academic achievement 10, anxiety 5, intelligence 20. Subject 10. Academic achievement 16, anxiety 7, and intelligence 25. A is academic achievement, B is anxiety, and C is intelligence. RAB is equal to minus 0.369, RAC is equal to 0.918, and followed by the RBC is equal to minus 0.245. And if we substitute the values of RAB, RBC, and RAC in the previous formula, then we get RA dot BC is equal to root of minus 0.369 square plus 0.689 square and minus 2 of 0.369 into 0.918 into minus 0.245 by 1 minus of minus 0.245 also. So RA dot BC is given by root of 0.818813 by 0.94 and RABC value is equal to 0.929. Multiple correlation coefficient. This means that a multiple correlation between academic achievement and the linear combination of intelligence and anxiety is 0.929, or approximately it is given as 0.93. Multiple correlation coefficient. The R square is the percentage of variance in academic achievement explained by the linear combination of intelligence and anxiety. If we look at this slide, it is given with Venn diagrams. There is no intersection in the first figure. There is no intersection between x and y, and r is equal to 0 followed by r square 0, and variance is also 0. In when we come to the second figure, there is a slight intersection between x and y, and r is equal to plus or minus 0.2, r is equal to r square is equal to 0.04, and variance is equal to 4%. And if you look at the third figure, there is a much intersection between x and y when compared to figures 2 and no. R is equal to plus or minus 0.4 and r square is equal to 0.16. And now if you look at figure 4, the intersection is almost half and r is equal to plus or minus 0.6 and r square is equal to 0.36 and variance is equal to 36%. If we look at figure 5, the intersection between x and y is almost full and r is equal to plus or minus 0.8 and r square is equal to 0.64 and variance is equal to 64%. If you look at figure 6, x and y both are equal and the full intersection is present. Then r is equal to plus or minus 1, r square is equal to 1 and variance is equal to 100%. Multiple correlation. A multiple correlation coefficient R yields a maximum degree of linear relationship that can be obtained between two or more independent variables and a single dependent variable. R is never signed as plus or minus. R square represents the proportion of the total variance in the dependent variable that can be accounted for by the independent variables. The independent variables are each optimally weight such that composite will have the largest possible correlation with the dependent variable because the determination of the weights beta coefficient is likely a in statistics always affected. The R is always inflated by sampling error. The multiple R is properly shrunken so as to correct for the bias owing to sampling error. Shrinkage of R is based on the number of independent variables and the sample size. R square is biased estimator. Adjust the value of R square. R square is now unbiased estimator. When the number of independent variables is small, that is less than 10, and the sample size is large, that is greater than 100, the shrinkage procedure has a negligible effect. Also, the correlations among the independent variables can be corrected that go into the calculation of R can be corrected for attention measurement error which increases R. Furthermore, R can be corrected for restriction of the range of ability in the particular sample when its variance of the on the variables entering into R is significantly different from the population variance. Assuming it is adequately estimated, correction of correlations for restriction of range is frequently used in studies based on study students in selective colleges. R square is equal to 1 minus of 1 minus r square of n minus 1 n minus by n minus k minus 1, where r square is equal to adjusted value of r square, k is equal to number of predicted variables, and n is equal to sample size. Because they typically represent only the upper half of the IQ distribution in general population. Two examples of the multiple R between several RT variables and a single IQ score are given below. To ensure a sharp distinction between RTs based on very simple ECTs and timed scores on conventional PTs, the following examples were selected to exclude any ECTs on which the mean RTs are greater than 1 for normal adults or 2 for young children. Obviously, not much cogitation can occur in this little time. The simplest example is the Hick paradigm. Jensen, 1987a, obtained value of R in large samples. Parameters of RT and MT derived from Hick data and with mean RTSD, the intercept and slope of regression of RT on which and in MT. R square is equal to 1 minus R square into n minus 1 by n minus k minus equal to 1 minus a 0.865 into 10 minus 1 by 10 minus 2 minus 1 is equal to 1 minus 1.217 by 7, that is equal to 0.826. Without corrections for attention and restriction of range in the sample, R is equal to 35. With both of these corrections, R is equal to 50. This is the best estimate we have of the population value of the largest correlation that can be obtained between a combination of variables obtained from the Higgs parameters and IQ as measured by one or another single test. Most often, the Raman matrices. Werner 1988 analyzed four independent studies. Null hypothesis: the population of R square is equal to 0. The average value of multiple R shrunken but not corrected for restriction of relating RT and IQ was 61, and for RTSD and IQR was 60. For RT and RTSD combined, R was 66. The statistical significance of R, the positive square root of R square, is tested via the analysis of variance subtle of table 6.2 by means of the F ratio. F is equal to 42.65, which with 2 and 9 degrees of freedom is highly significant at the alpha is equal to 0.01 level. Thus, as described in chapter 1, the equivalent null hypothesis Rp is equal to 0, beta 1 and beta 2 is equal to 0 are rejected at the 0.01 level, and we conclude that multiple correlation is significant. If calculated value less than or equal to critical value, we shall accept the null hypothesis. If calculated value greater than critical value, the null hypothesis is rejected. I hope you gain some knowledge regarding multiple correlation null hypothesis. This is the end of my presentation. Thank you.